For problem 29, all the baseballs are thrown at the same height. Now they have velocity, which is, and your initial velocity is not just in the x direction, it has a y component as well, except for b here because the angle is 0. You want to rank the baseballs on the basis of the max height above the ground. Well, they're all starting off from the same height, but b is not going to go any higher because the angle is 0 degrees, so b is going to be the smallest. Now, if the velocity was the same and you're just changing the angle, then f would go the highest, but because you're changing the speed and the angle, you have to consider both of those. So if you take your velocity and you break it down into x and y components, the x component is not going to affect the max height, so we're just interested in the y component. The y component of the initial velocity, that would be take your vector here, break it down into a y component, and the x component, which we're not going to use, not yet. And so the y component, that would be v, that's the magnitude of this vector here. That's just what they give us here. Let's just call it v. So v, that would be, this is the sine component. So that's v sine theta. And the max height is going to be greater when v sine theta is greater. So I don't want to do all the calculations here, but you can check on your own. So use what they give you here, find v sine theta. The max height is the greatest when v sine theta is the greatest, and if you take the numbers and plug them in to your calculator, you should get this ranking. Okay, so you can finish that on your own.